Hi, in this video we will be discussing about array implementation of list using C. There are two popular implementation of list. One is using arrays, that is available in most of the languages, and the other way of implementing is linked list implementation. First we will be talking about array implementation, and then we will be discussing about what are the drawbacks, and then what is the necessity for linked list, when we have to go for array implementation and when we have to go for linked list implementation. Okay. So here we will be concentrating on implementing these four basic operations of list. Create a list. Okay, so creates an empty list. This create list, we are going to create an empty list, and destroy list, we are going to delete the list itself, and print list will print the elements of the list. This is to check whether everything is going fine or not. Print operation is basically required. And then we have got isEmpty function. IsEmpty function will return true if the list is empty and false otherwise. Similarly, IsFull will return true if the list is full and false otherwise. Let us look at the operations. When you want to print the element, what can be a simple algorithm that we can think of when we want to print the elements is, first of all we have to know how many elements are there. Okay, so we should be knowing the number of elements in the list so that you will be able to print it, right? So number of elements is very important, which is required for us to implement the print function. And then isEmpty. When you will tell the list is empty, if the list do not have any elements, then we have to tell that it is empty, isn't it? So yeah, this number of elements will help us. So if the number of elements in the list is 0, if it is 0, then we can tell that the list is empty, and if it is not 0, then we can tell it is not empty, right? So for implementing isEmpty also, it's enough if you know the number of elements in the list. Next is the isFull operation. So how will we think of the isFull? When you will tell the list is full, if the elements, if the memory is fully occupied, that is, there is a capacity for the list. If the capacity is full, or if the number of elements is equal to the capacity, then we can tell the list is full. Okay, all the spaces is being already occupied, there is no space. So in that case you can tell the list is full. Okay, so when we look at this, we need to have few certain properties for the list. Okay, one is the elements that are actually going to be the part of the list, and next one is the number of elements. This number of elements will be helpful in many places. Like when you want to print the elements, you have to know how many elements are there, then only you will be able to iterate through the list and then print. Also when you want to check isFull also, you need to know the number of elements that is currently in the list. IsEmpty also you have to know. And next important thing is capacity. This capacity is going to tell us what is the maximum number of elements that can be held by the list. Okay, so these three are going to be, whenever we are going to implement structure, we should identify what should be the members or what should be the properties of the particular structure. Okay, of course we have defined operations already, we have seen we can do insertion, deletion, everything. When we want to do some operations, there should be some properties, and that is required for implementing the operation, that should be identified. So for list, that particularly array implementation, we identify these three as the properties required for the list. Okay, so we have to put everything together. All the properties should be put together as a list. When you want to represent the list, we have to represent by all these three properties put together. So how we can put together is, we will go for structures. Okay, so we will go for structures to put all these three things together. So let us start our implementation. Yeah, so first I have included the header files stdio.h and stdlib.h. This is C implementation, isn't it? So first thing I will be doing is, I will be writing a structure, and let me call that as list is the name of the structure, and then I will be telling what are the elements in this. So I am going to dynamically allocate the memory for the elements, right? Basically it's going to be array, but I am not telling that it is like 20 or 30. I am not going to restrict like that. Instead, what I am going to do is I am going to read the capacity from the user. Based on the capacity given by the user, I am going to allocate memory for the array, right? So in star elements, I am just creating a pointer alone, and I will be allocating the memory in the CreateList function. And then I have to have number of elements, right? And then I have to have a capacity. So these are all going to be the members or properties of the list, right? And what we have to do now is we have to start implementing the functions one by one, the operations. First one is CreateList. Okay, so let us implement the CreateList function. So how will we write? CreateList is the name of the function. Let us follow a uniform way of naming, capital letter for each word. So CreateList, and what I am going to do is I am going to read the capacity required by the user through the terminal, and then I am going to pass that as a parameter. So CreateList actually takes a capacity as the parameter, and it will be allocating memory to the specified capacity and do other kind of initializations also. So CreateList will create the list and return a list. So the return type is also list, and let us now do. I will tell capacity is equal to C. Capacity is equal to C, and then I am going to allocate the memory. So elements equal to, we know that we can use malloc function, right? Size of, I am going to allocate for int. So size of int into how many pieces of memory I require equal to the capacity. So size of int into C. Okay, this is what I should do, and malloc returns a void pointer because it's a common function for allocating any type of memory, and it has to return the address of the first byte of the allocated memory. So its return type is actually void star. Void star means it's a generic pointer. In C, it is a must that you have to typecast to the data type whatever you want, you use here. Here we used to allocate the memory for integers, so we are converting that to int star. Okay, so we have initialized capacity, we have allocated the memory. Next thing is we have to initialize the number of elements also. You tell the number of elements is 0. Okay, so this is how we will create the list, and then let us try to use it in the main. How will we use it in the main? I will call CreateList. Actually it will create a list and it will return the list. So I need a variable to hold the return thing, isn't it? So let me tell list L, and then I have to read the capacity from the user. So I need to have int n. Let me use scanf to read the capacity from the user. N, here I am using n to represent the capacity, and then you call CreateList and n, right? So you pass n and it will return a list. Let us hold n L. Fine. Okay, so this looks fine. Let us try to compile the code and see. Let me compile. Yeah, you see some error, right? Okay, a few errors are due to the usage. This error, a list is not known. We will come to that, right? But look at the errors, that is capacity is undeclared and so on. That is because capacity, I cannot tell like this. I have to create a list here. Okay, let me tell list L, and then I have to tell L dot capacity is equal to C, and then I have to tell similarly L dot element is equal to memory allocation, right? Similarly, I have to tell L dot number of elements is equal to this, and similarly I have to return also, I missed that also, return L, right. Let us save the code and try to run it again. Yeah, so now you see everywhere it doesn't know, right. It doesn't know what is list, right. So why this is happening? Whereas let me use a G++ compiler and show you. G++ means it's a C++ compiler. C++ is a superset of C, so it can compile the C code also, right. It can also compile the C code. You see that you don't find any error. Then why when I am using a C compiler I am getting error? It is because C++ actually use struct as it type defined by default, whereas in C we have to do explicitly, right. So what we have to do here is you give type def struct list, and here also you give list. That is, you are defining a new type. That's how this type def will be used. You can define a new data type itself. So type def struct list, you can use the same name here, like this is the new name that should be used, but both can be same, or that's better. Okay, let us have both the names same. Everywhere we will follow this. Now let us compile and see, right. But 1 minute. Yeah, that was because I didn't save. Let me save it once and try. Yeah, now the C compiler also doesn't give any error, isn't it? Yeah. So this is done. So please remember that if you are using a C compiler and you have to use a structure, and otherwise you have to use everywhere struct keyword. Nothing wrong. You can still ignore this type def. Only thing is, wherever I use list, I should use the keyword struct before it, struct list everywhere. Otherwise it will give some kind of errors like what we have seen. To avoid that, better thing is type def it, so that it will be very peaceful during your implementation, right. So we have returned the create list. Next what we will do is we will write the print function. So the print function is not going to return anything. So let it be print list, right, and we will get the list as a parameter here, right. Yeah, so here I will be telling int I for I equal to 0, I less than, you can tell L dot number of elements, right, I plus plus. Okay, so we are going to just loop through till the number of elements is lesser than I is less than the number of elements, and then we are going to print, right. So printf, I can tell printf %d, and then let us give new line character so that it will, each value will be in one line, and then we are going to print actually the elements inside the list. So elements of I, right, and let us call this function here create list, and after this we are going to call print list, and you pass the list whichever you have created, right. And how do we expect to do, because I haven't initialized the elements, I have just got the memory from the heap, that is using the malloc we have dynamically allocated the memory, but we haven't initialized. So let us execute and see. If I tell 3, and yeah, if I tell 3, it should be printing 3. Okay, so print list I am telling here number of elements, so I am not able to see. Let us give capacity time being, actually we should print till number of elements only, but I am just giving as capacity since we have not inserted any element, right. So I will print all the values and see now. When I give 3, you will see that some garbage value has to be printed, but in my machine I am getting it as 0, but there is no guarantee that always you will get 0. You will get some garbage values, right, because the memory is not initialized. So print list is done. Next is destroy list. Okay, so the functionality of destroy list is actually it has to free the memory. If you have dynamically allocated using malloc in the create list, we have to give back the memory. That is what is expected in destroy list. And when we look at our create list, we have used malloc, so we have to use free to free the elements, right? So let us tell free and then L dot elements, right? You can use that. Yeah. So this is how we will be writing the destroy list. Destroy list is actually giving back if any dynamic memory allocation is done. And the next functions that we are going to implement are, we are going to implement IsEmpty function and IsFull function. When we look at the IsEmpty function and IsFull function, they should return true and false, but bool is not a native data type, or even it is not a morphed data type in C language. We do not have an option, so let us return an integer. Okay, so we will return 0 to indicate false and 1 to indicate true, right? So int is empty, I can use that. Okay, int, it's going to return an integer is empty, and you should take the list as the argument. And let us check if, what should we check here? If the number of elements, right, L dot number of elements, I should not miss it, L dot number of elements equal to 0. If the number of elements is 0, then you will be returning 1, right? Otherwise you will return 0, but since we are returning in the if part, right, that is in the if body of the if, we have put a return. So if the condition is satisfied, obviously the code might have returned to the place where it was called. If it is not returning, then it will come to the next line. So it's obvious that else is not required, but it's your choice. I am not putting a else due to that reason, and then I am checking is full, right? I am writing the is full function. So is full also takes a list, and we will check here if L dot capacity is equal to L dot number of elements, right? If the capacity is equal to number of elements, then we will return 1, otherwise you will return 0, but as I told you, no need to have a else, as we are returning at the body of the if also, right? Fine. So we can also call this functions and check. We can print, okay, printf. I will first call IsEmpty. IsEmpty should return us true. Next I will call IsFull. IsFull should return us false. Yeah. So let us insert a new line character after this also, right? Let us go to the terminal, try to compile code and find out if there is any error. Yeah, unknown type. This is because capital letter is used here. Actually it is okay. Yeah, we have got IsEmpty. We can check, yeah, capital letter once again due to the case sensitiveness. IsEmpty is full, right? And yeah, that is because I have given L dot, that is wrong. Yes, printf, okay. Yes, so let me give the size to be 5. You see, I am printing the elements, 5 elements are getting printed, and here I am checking if the list is empty, it is returning true, so 1, and here I am checking whether the list is full, for that I am getting false, right? And let us just picturize the code, how it will be working. We will be often discussing about this call stack whenever we need to know about it, right? So here also we are going to see the call stack. Actually the program execution, as we already know, will begin in the main. You have got a list L, right? So for L, memory will be allocated with 3 parts. one for the elements, okay, because list contains three parts: elements, number of elements, and then the capacity. So you will be having like this, and then you have got n. For that also memory will be allocated. You will be getting the value of n, right, from the user. I gave 5, so 5 will be stored here, and then you will be you're calling the create list. So when you call the create list, the call stack is growing here. This is the space for create list. Actually this is the space for main, okay. Under this create list space you are passing n. So that n, actually here, let us see, I think we call it as C. So it will be having C, okay. It will be having C. Sorry, it will be calling, we will be calling this a C, and 5 will be stored here. 5 will be copied here, and then we are creating a list L, right. So L is created. Obviously there are three parts, since the it's a structured variable and has got 3 members in it, right. And then you are dynamically allocating the memory, right, of size 5 is being allocated, and then the address will be stored in the elements part, and then you initialize the number of elements to 0, and then you are initializing the capacity equal to 5, right. If this is the space for capacity, this is for number of elements. This is how the list will look like after we finish all these code. And you are telling return L. This is by value. So what will happen is, this memory, this particular memory you can take, this particular memory is dynamically allocated, right. We have used the malloc and we have got it. So this memory will be available to us till we free it, till I use the first byte's address. If I use the first byte address and free, then only the memory will be given back. Till that the memory is yours, right. So you can definitely use the address. If it is a local thing, if I have not given it as a pointer, if I have just given as elements of some 20 or something, then it is going to be static memory allocation. In that case, the memory will be given back as soon as the end of the function is reached. But here we are dynamically allocating using the malloc operator, malloc function, okay. So this memory will be with you till you use free for that particular memory, right. Okay, so the address, the corresponding address, for example, if it is 0x1079, that will be copied there, and 0 will be copied, and then 5 will be copied. After this particular function call, L will be containing the values like this, and then we call print list of L. So you pass this, actually these values will be copied, the call stack will be growing. So this will be the space for print list, and there you will be having a space with the address 05, okay. This is how it will be. And how our print list will work? Our print list, now we have asked it to go till the capacity, so it is going to refer to this memory only, right. All the 5 spaces are going to be seen and the values are going to be printed. After it is printed, it's coming back and you're checking IsEmpty, okay. So IsEmpty also takes the list. So each time you pass the value L, this entire block will be copied into that particular memory space, but we have allocated the memory dynamically as I told you. So this memory will be available with us. This is how it is working. I hope this is clear, the implementation. We have just done the 4 basic operations of list. I'll be pushing this in the GitHub, and I'll be providing the link in the description box. You can go and refer the code. Thank you.